Good morning. Today I'm going to do with laws of motion. The second part is I have divided laws of motion into two parts. We referred to the earlier parts such as the mass and everything. And today I said I will go with, yesterday we studied about Newton's 3 laws of motion, inertia, apparent weight and everything. Today I'm going to go with frictional force, friction and dynamics of circular motion, right? Friction is the opposing force. Before that, let me, this is the clay 6 page. I have opened this for you. You can as well go to the practice session. Log on to clay6.com. Click on the practice section. You have all the packages. Now go to the NEET premium package. We have the revision notes here. See the revision notes. We have actually summarized for all the topics of physics, chemistry, and biology, which is very, very essential for the NEET exams. The important formulae, the important notes which you have to memorize and which you have to learn. It is enough if you memorize all these formulae. All the topics are given. You can as well go through that, and the packages offered is also being given. And see, right from units and measurements till the end of the chapter, that is semiconductors and devices, everything is included in this. Everything is given as chapter wise. Important notes and important formulae, everything is being summarized. So it is enough if you learn these formulae and apply these in the questions to come in the NEET exams. So when I talk about this laws of motion, the percentage is, this is a very, very important topic, children. You have kinematics and laws of motion are very important. The weightage is now going to be 3% for this particular chapter. Means you can expect at least 1 to 2 questions from this chapter. Is that okay? Now coming to the revision part. See, I said I will go with frictional force. What is a frictional force? Friction is nothing but the opposing force that comes into play when one body is actually moving over the surface of another body is trying to move over the surface of the other. So it's more like the resistance offered by the surface, you can say. So whenever the surface is now going to be very, very rough, then the frictional force is said to be more, and the force of addition later on we'll be studying in the properties of matter also. The friction, the force of addition between the molecules is now going to be also related to this. We'll be studying more about that in the properties of matter. Now when I talk, now see the friction. Now when I talk about the friction, there are limiting friction. Limiting friction is the maximum value of the static friction. What is static friction? Static friction is nothing but a self-adjusting force. It's a self-adjusting force. Limiting friction is the maximum value of static friction. So friction basically can call it as a dynamic or kinetic friction. That is when the object is in the motion, when the object is moving, it is somewhat, you can say that the kinetic friction is somewhat less than the limiting friction. Okay. So static friction is the self-adjusting force. Rolling friction is slightly less than the sliding friction. When I talk about the laws of limiting friction, first law states that F is directly proportional to R, where F stands for force and R is the normal reaction. Remember, sometimes it is denoted by N and sometimes denoted by R also. Okay? Now coming to the second law, direction of force is opposite to the intended direction of motion. The third law, F does not depend upon the actual area of contact. Fourth law, F depends upon the nature of material and nature of polish of the surfaces in contact. So these are the important laws you'll have to know. Coming back to the notes now, I can now tell you. See, coefficient of static friction. See, it now states that coefficient of static friction, US is equal to FL by N, where FL is going to be the force of limiting friction I told you N, normal reaction. N is a normal reaction. It is always denoted by either N or R. Okay. Mu K, coefficient of dynamic friction, which is equal to Fk by N, and Fk is equal to the force of dynamic friction. Acceleration of, okay, these are the important points related to friction which you have to know. Mu K stands for the coefficient of dynamic or kinetic friction. You can also call it as the dynamic friction or kinetic friction, right? Next, coming to the acceleration part, see, this is now going to be a block of wood, or block of any object, which is now going to be moving along an inclined plane. This is called as the FBD, that is the free body diagram. Whenever an object, you are going to project like this and you are going to resolve it into their respective components. Now you can see that the weight or the force which is equal to mg is now going to act downwards. Mg is now going to be, so since it is now going to be along the resultant, it can be resolved into two components, that is mg sine theta and mg cos theta. You can always see that mg cos theta and the normal reaction, they are always equal and opposite. So they will cancel out each other. So the only force which is now going to act is mg sine theta, right? So A is equal to g sine theta minus mu g. Next is the circular motion. So we were talking about this. I told you I will quickly go through the before coming to that, before going to the circular motion, I want to cover certain facts related to friction also. That is, I told you frictional force, right? Frictional force or coefficient of friction, mu. It is denoted by mu. Mu is equal to F by R, where F is now going to be the force, frictional force, divided by the reaction. Remember that. F mu is equal to F by R. If angle of friction theta, what is angle of friction? This is the angle which the resultant of F and R makes in the direction of R. Okay. So the relation between mu and theta is given as mu is equal to tan theta. That is what we saw here. Mu is equal to tan theta. Remember? Mu is equal, it is given here in the circular motion. Remember, mu is equal to tan theta. Angle of repose. It is a minimum angle of inclination of a plane with the horizontal such that a body placed in the plane just begins to slide down. So you saw the object is now going to be sliding down. This is called as the, so which is now made with the inclined plane with the axis. That is called as the angle of repose. It is a minimum angle of inclination of the plane with the horizontal. Okay, such that the object which is now going to be placed is now going to it is now going to slide down. Okay. Now coming to acceleration. Acceleration of a body down a rough inclined plane is A is equal to g sine theta minus mu cos theta. What is going to be the work done? Always, you know, work done is force into displacement. Here the force is now going to be nothing but the frictional force. Already we saw frictional force is nothing but mu r. So mu r into S. So I can put W is equal to mu r into S, or simply mu mg into S. Okay. Work done in moving on a body or a rough inclined plane, as in this case. If it is now going to be, that was along the straight line. This is now going to be along a rough inclined plane. Then you can say W is equal to mg into sine theta plus mu cos theta into S. So here the frictional force is nothing but mg sine theta plus mu cos theta into S. Of course, you might think, can't we avoid friction? Friction is a necessary evil, because without friction, we won't be able to walk. Walking is also one effect of friction. Some methods, of course, you can reduce friction. So let us look into the methods by which you can reduce friction, like polishing, lubrication, streamlining the shape, etc. By these methods, you can actually reduce friction. Now coming to the centripetal force. Whenever we talk about circular motion, you know, there are two types of circular motion force. You can call the circular motion as an accelerated motion because the velocity keeps on changing every time. And there are two types of forces which are now going to act here. One is going to be the centripetal force and the other is the centrifugal force. The centripetal force is now going to act always towards the center, and the centripetal is now going to act towards the center, and the centrifugal will be always away from the center. So centripetal force is the force required to move the object uniformly in a circle. So this is very, very important. So here we are in a when we consider the circular motion, we are going to talk more about the centripetal force here. Okay. So magnitude of this force is now given by F is equal to mv squared by r. Remember, it is given by mv squared by r. Or you can also say v squared by r is given by v squared by r squared is given by omega squared. You can also say it as mr omega squared, okay, where omega is the angular acceleration. So it acts along the radius and it is always pointed towards directed towards the center of the circle. Remember that. And I was talking about the centrifugal force also. Centrifugal force also acts along the circular path, but it has a tendency to regain the object to the original or the straight line path. Okay. So centrifugal force can be treated as the reaction. It is now going to be the opposite of the centripetal force. So it is, if this is now going to be the action, that is now going to be the reaction. So if centripetal force is going to be the action, centrifugal force will be the reaction. So the magnitude of centrifugal force is same as that of the centripetal force. Remember, both are equal and opposite. Remember that. So the direction of centrifugal force is always along the radius and it is always away from the center. Remember that. Okay. While going around the circle, now this is now going to be we are going to talk about the circular motion of a car. So you might see sometimes the roads are curved, is it not? How does these automobiles or vehicles or cycles, how it is now going to manage this curve? Let us see what are the formulae you'll have to undergo, or you have to learn while tackling such problems, or let's see. While rounding a level curved road, the necessary centripetal force is provided by the force of friction between the tire and the road. Remember that. Okay. What is going to be the centripetal force provided? It is now going to be provided by the force of friction between the tires and the road. So the maximum velocity with which the vehicle can go round the level curve without skidding, you can see it is given by, see, V max is equal to root of mu rg. F is lesser than equal to, so centripetal force required for circular motion is given by the frictional force I said. So F should be lesser than equal to mv squared by r, or from this equation we can derive that v squared is lesser than equal to mu rg when you substitute for F, and V max is equal to root of mu rg. From this we derive the equation V max is equal to root of mu rg. So motion of a car on a banked road where theta is going to be the angle of banking. You would have seen what is banking? Banking is nothing but while moving along the roads when they are along the curved path, you can see the outer circle is slightly raised. You can always see that this is to avoid the curved roads are usually banked. This is called as the banking of the curve. That is the outer edge of the curved road is raised suitably above the inner edge. Suppose if theta is going to be the angle of banking, then it is given as r cos theta is equal to mg and r sin theta is equal to mv squared by r, and tan theta is equal to v squared by r. Remember that. Okay. Yeah, that is given. Okay. So when a cyclist, so we can now see that angle made by the resultant force, resultant of FL, and the normal, that is where FL is the limiting friction, okay, and the normal reaction is called as the angle of friction. Here we take it as tan lambda is equal to FL by N. I told you N is the normal reaction and FL is the limiting friction, which is given by mu N by N, which is equal to mu. So whenever the body is resting in the inclined plane, you can now say, I told you, I gave you earlier that for both along the straight line and the whenever it is going, work done by the body over a rough horizontal plane is given by mu mg into S, and work done in the moving a body over rough inclined plane is given by W is equal to mg sine theta plus mu cos theta into S. So whenever there is friction, we are now going to consider this coefficient of friction. Remember that. Now, let us quickly go to the problems. Let's see how to solve the problems. How can you take the clay 6 tests? Now we have given subject-wise tests for, you can see, for physics, chemistry, biology, class 11 and class 12. You've got lots of tests. You have NEET full tests also, full length tests. You have about 38 tests. And whenever you want to take a test, what you do is click on that particular subject. You can see the blue bubble, red bubble, yellow bubble, and the green bubble. Blue bubble says you have not taken the test yet. Red is for random tests. Yellow is you have attempted and quitted the half of the test. And green bubble states that you have already taken the test. But anyways, you can go it any number of times. You can do it any number of times. Even if you have attempted the test, you can take the test again and again until you are thorough about of the concepts. Right? Now I'm going to attempt the 5th test. I'm clicking on it. It takes click on take test. Go to test. Okay. Coming to the first question. A horizontal force F is applied on a rod inserted between 2 identical blocks A and B placed over a rough surface. See, it is given as rough surface. That means friction is now going to play. So force F is gradually increased. Then which of the block will move first? Let's quickly solve that. Now what is going to be the net force here? Net force is given by F1 minus F2, which is equal to F. That is, F1 is now going to be due to the block of mass M1 or block A. In this case, it is given as block A, right? So block A, and F2 is now going to be that of block B. Okay, so let me take this as A and this as B. Okay, so the force is now going to be like this. You can put it like, say, this force, and they are now see that it is given that they are now going to act along the rough surface. So the force is now going to be, so now you can see the force applied is now going to be when I say, I can now put it by say this is now going to be, F is now going to be like this. This obviously it is touching here. My diagram is not perfect, so it is going like that. Now you can see the force is also going to be in this direction also. Okay, so since it is touching, you can see that it is also going in that direction. So obviously you can see that F1 is now, so this is now going to be F1 and this is now going to be F2. Okay, this is now going to be F1 and this is now going to be F2. Obviously you can see that F1 minus F2 is, F1 is greater than F2. So block B will move first. Okay, let's block B. The option is correct. Save that. Go to the next. A disc of mass 10 grams is kept horizontally in air by firing bullets of mass 5 grams each at the rate of 10 per second. If the bullet rebounds with the velocity, rebounds with which the bullets are fired. Now he is asking you at what rate it is now rebounding back. Let's solve this. Now the mass of the disc is given by 10 by 1000 kg. Right? Let the speed of the bullet be v. Speed of the bullet v equals v. Now the change in momentum per second is given by change in momentum per second is given by 2 mvn, where m stands for mass, v the velocity, and n the number of bullets. Okay, N is now going to be the number of bullets. Therefore, what is now going to be the force applied by the bullet on the disc is now going to be, let us say, force applied by the bullet on the disc is now going to be 2 mvn, which is equal to into G, right? Into G. So that is equal to 10 by 100 into G, which is equal to 0.2 into 10 into, we know that it is already, F is now going to be 10 into 100 into G, so mg. So that is now going to be 0.2 times G is taken as, because he said take G as 10, I'm taking it as 10 into 5 by 100 B, which is equal to, when you calculate and simplify that and calculate, you get it as 98 centimeters per second. Let's quickly see which option is correct. 98 centimeters per second. Right? Click that. Go to the next question. A fireman has to carry an injured person of mass 40 kg from the top of a building with the help of a rope which can withstand a load of 100 kg. The acceleration of the fireman in his, if his mass is 80 kg, will be what? Let's quickly solve that. Okay. Now the total mass is given by 80 plus 40. You have to take both the mass. Look, it is the mass of the injured person as well as the fireman. That is 80 plus 40, which is now going to be, so let me put this, 80 plus 40, which is equal to 120 kg. Rope cannot withstand this load, so he has to slide down with an acceleration. Okay, since the rope cannot withstand this load, he has to slide down. So let us take the, what will be the maximum tension? So let me put it as T max. That is going to be equal to 100 into 9.8 times 9.8 newtons. Now you know that is nothing but, you have seen already in the revision notes, we have seen that T max is given by M into G minus A. So T max is equal to M into G minus A. Okay. So that is now going to be equal to 100 into, so this is now going to be equal to 100 into 9.8. Okay. That is equal to 100 into 9. So now M is given as 120, G is 9.8. From this, we'll have to calculate A. So let us equate both. So that is now going to be 120 times 9.8 minus A is equal to 980. After simplifying, you get A is equal to 1.63 meters per second square. 1.63 meters per second square. 1.63 meters per second square. Let's see which option is correct. 1.63, yeah. Click that. Go to the next. Let me clear this. Yeah. A body A of mass 1 kg is resting on a table and connected to a body B and C as shown. The surface are smooth and the string and spring are massless. The string is inextensible. Find the extension in the spring if the force constant of spring is equal to K, where the spring constant K is given as 50 newtons per meters. And he is also asking us to take G is equal to 10 meters per second squared. See, 1 kg mass, it is going over a frictionless pulley. B is of mass 2 kg, and then there is a spring which has a C which has a mass of 3 kg. Now let us quickly solve this. First of all, let me draw the free body diagram. Before that, yes. This is Kx. This is now going to be the reaction upwards. Mass is 3 kg, 3 grams. Let me see this. 3 kg. Yeah, 3 kg. Yes. 3 kg. Now, it is very clear from the figure. You can see that it is now going to, the acceleration is now going to be downwards. Okay. So let me mark it. Acceleration is downwards. So since you know weight is equal to mg, let me take this as 30 newtons. Okay. This is now. Now for the system, net pulling force is due to the mass B and mass C. See, you can see this. Mass B and mass C, right? So then F is equal to 2 plus 3 G, right? Which is equal to 5 into 10, which is equal to 50 newtons. Okay. So the force due to the both the masses 2 kg and 3 kg is now going to be 50. What is now going to be the total mass which is to be pulled? It is now you have to consider all the three, 1, 2, and 3. Now add everything up. So that will give you 1 plus 2 plus 3, which is equal to 6 kg, right? 6 kg. So what will be the acceleration? Now acceleration is 50 by 6. So A is equal to 50 by 6 meters per second square. So from the FBD, you can see that 30 minus kx, 30 minus kx is equal to ma. You can see that the action and reaction are equal. So this is now going to be, action is 30 minus kx, which is now equal, you can equate it to the force, which is equal to ma. Okay. So we have the, here we know k, we know m, we know a. Substitute all the values and find out x. Yeah. So 30 minus k is given as, let's see, the value of k is given as 50. Okay. Now I can write it as 50, which is equal to, mass is given as 3, acceleration is 50 over 6. We calculate it. So simplify this and you can see that kx is equal to 50x. I'm sorry, 50x. So x is equal to 5 by 50. You get it as, you can see that you are getting it as 5 by 50, which is equal to 0.1. Okay, 0.1. Let's see which option is correct. 0.1 meter. Yes. Pick that. Go to the next. Fifth one. A ball of mass 1 kg is at rest in position P by means of two light strings OP and RP. The string RP is now cut and the ball swings to position Q. If theta is the angle, that is, it is given as 45 degrees, find the tension in the string OQ when RP is cut. When RP is cut. Okay. You take G as 10 meters per second square. Okay. Now let's go to this. Let me clear this off. Let us draw the diagram. Let me mark this as O. Now, at this stage, you can see the balls are here. Okay. The resultant is now going to be mg here. Okay, this is now going to be mg. And let me mark it as m2g, and this is m1g. Okay, so obviously you can see that this is now going to be the resultant components. Okay. This is along the tension. The tension is now going to be the let me mark this as T1 and this is T2. This is now going to be mg, right? So here, just a second. This is let me mark this clearly for you. So this is now going to be mg cos theta, and obviously that is perpendicular to that will be mg. So this is now we have taken this mass as m2, right? m2g cos theta and m2g sin theta. So the weight is now going to be along this direction. Right? So this is now going to be theta. This angle is now going to be theta. Now you can, same way here also, it is now going to be m1, this is now going to be m1g. Obviously, this is now going to be m1g sin theta. and this is now going to be mg cos theta, right? This is going to be mg cos theta. Now, in both the figures, you can see that the net force is now going to act along. Okay, let me mark this as P. This is given as Q, and this is, oh, sorry, this is P. Wait, let me rub this. So this is P, and this is Q. Okay, this is Q. So now you can see that the net force acting along OQ, that is in this direction, along OQ, is 0 because T2 and mg cos theta, they are now going to cancel out each other. Okay. So, or in other words, I can put the net force which is now going to act is now going to be, that is T2, or in other words, you can say T2 is equal to mg cos theta because they are now going to be equal and opposite. Now, it is given theta is equal to 45 degrees. Okay. Theta is given as 45 degrees. Now, substitute in the place of cos theta, then you get it as is equal to mg cos 45, you know, is 1 by root 2. Okay, you take it as 1 by root 2. That is given as m is 1, g you take it as 10, which is now going to be 1 into 10 into 1 by root 2, or simply you can write this 5 root 2 m. Let's see which option is correct. 5 root 2 m, yes. No, B is correct. Save that, go to the next. Next is all surfaces are smooth in the figure. Find F such that block of mass M resting on a wedge of mass M remains stationary with respect to wedge. When will it be stationary? What will be the force so that it is now going to be stationary on the wedge? Now let us quickly go to that. Let me draw the FBD so that you can understand it. Yeah. So let us take this as the inclined plane, and the wedge is now going to be here. So you can see that this is now going to be the reaction here. Okay, this is now going to be N, and this is now going to be mg. Okay. Obviously, N is resultant, so that can be resolved into two components: N sin theta and N cos theta. N sin theta and cos theta. So let this angle be theta. Okay. So this is going to be the FBD diagram of the block of mass M. So the block moves with acceleration A with respect to the ground. Okay. The block is moving with acceleration. Let us take the acceleration to be A. So in that case, A should be equal to F by M plus M. Okay. Let us take it as force by mass, but here the mass is now going to be M plus M. Okay. So now you know the net force is now going to be 0. That means the N cos theta component is now, because you can see they are now going to be equal and opposites, right? So we can say N cos theta is now going to be N cos theta is equal to mg, right? N cos theta is equal to mg. That is sigma Fy. The net force acting along the y direction is going to be 0. Then sigma Fx is now going to be 0. I can say N sin theta is equal to ma. Divide both, you get A to be equal to G tan theta, right? I'm dividing this and this. 1 divided by 2 will give me N and N will get cancelled. The M and N will get cancelled. So you get it sin theta by cos theta as tan theta. So you get A to be equal to G tan theta. Now, you know, F is equal to, or you can simply say F is equal to A times M plus M. But what is A? Nothing but G tan theta. Substitute for that. So that gives you G tan theta into M plus M. Let's see which option is correct. So option D, M plus M tan theta, G tan theta. So option D is correct. Save that. Go to the next. A man is standing stationary with respect to a horizontal conveyor belt that is accelerating with 1 meters per second squared. What is the net force on the man if the coefficient of static friction between the man's shoes and belt is 0.2? Up to what acceleration of belt can the man continue to be stationary relative to the belt? Mass of the man is given as 65 kg and g is equal to 9.8 meters per second square, right? Right. Let us go to this. Now, the man is stationary on the belt, he says. So acceleration of the mass is equal to the acceleration, acceleration of the man is equal to the acceleration of the belt. Okay. Whatever is now going to be the acceleration of the belt is now going to be the acceleration of the man. So net force on the man is now going to be, let us take F is equal to MA. Okay, let us take F is equal to MA, which is equal to 65 newtons. So since we are taking it as force, 65 newtons. Okay, 65 newtons. 65 into 1, which is equal to 65 newtons. Now, coefficient of friction mu is given as mu is equal to 0.2. Just a second, children. Let me check my pen pressure. I think that is troubling. So, mu is equal to 0.2. So, the limiting friction mu L is given as mu mg. It is given as mu mg. Now, having known all values, you can, for the man to be stationary with respect to the belt, accelerating with A0. Let us take the acceleration of the belt to be A0. Then we can say MA0 is equal to mu mg. Or we need to calculate A0, right? Which is equal to 0.2 times 9.8, which is equal to 1.96 meters per second square. Right? So let's see which option is correct. Option A, 1.96 meters per second. So save that, go to the next. With what acceleration A should the box in the figure descend so that a body of mass M placed in it exerts a force of mg by 4 on the base? That's quite simple. So the box is given. You can see the diagram here. The box is given and the mass is now going to be there. Now you can see the acceleration is acting downwards, right? Obviously, the box is accelerated downwards. Then what will be the force? You can write it as mg minus n is equal to ma. The force mg minus n should be where n is going to be the reaction, mass is given m, g is going to be the acceleration due to gravity, and here the a is now going to be the acceleration of the box. Remember that. So normal n is going to be the reaction. This is now going to be the normal force. I told you it can either be denoted by r or n. So n is equal to, he says it is mg by 4. N is given as mg by 4, right? So, okay, it's capital M. So I can now substitute, and so A will be equal to 3g by 4, right? So let's see. After substituting that, you can find it out. It is now going to be 3g by 4. Let's see which option is correct. 3g by 4, option A is correct. Okay, save that, go to the next. Two beads A and B move along a semicircular wire frame as shown. The beads are connected by an inelastic string which always remains tight. At an instant, the speed of A is u, angle BAC is 45 degrees and angle BOC is 75 degrees, where O is the center of the semicircular arc. The speed of the bead B at that instant is what? Let us quickly draw the diagram. So it is now going to be a semicircular arc. Okay. Let us take this bead is now going to be on this particular point. So it is now going to be acting along. Okay. Let me mark this point as A and B. So obviously this is now going to be the centripetal force acting B. Okay. And he says this center. Let us take the center to be O, right? Let that be O. And this angle is now going to be 75 degrees. Okay, that is 75 degrees. And obviously, okay, I didn't mark this straight. It should be like this. So this angle is 30 degrees. Okay, that angle is 30 degrees. Now we can resolve this, and this angle is now going to be okay. Now let us see that this is now going to be u cos theta, and one which is going to be perpendicular to that will be equal to u sin theta. Okay, the velocity at this particular instant is now going to be resolved into two components, u sin theta and u cos theta. And here, velocity at this instant, the centripetal velocity. Here it is now going to be centripetal force is B cos alpha, and this angle is given as 30 degrees. Okay, that angle is given as 30. Oh, sorry, let us take it as alpha. I'm sorry. Later on, we can say that they are equal. So that is now going to be alpha. Let us take that alpha. Okay. So I'll explain this diagram again. See, this is the the bead is moving along this string in a circular motion. It is now going to undergo a circular motion. I have drawn one part of the circle, that is the semicircular part. Let B be the speed of the bead, since the string now the string is remaining tight, right? So it has to be undergoing some tension. So velocity of the component A and B along the component A and B should be the same. That means, in other words, I can put it as u cos theta is equal to v cos alpha. Okay, u cos theta is equal to v cos alpha. Now, given theta is equal to 45 degrees, obviously you can see that theta is equal to alpha is equal to 45 degrees, right? So let me substitute that. In that case, I'll get it as 1 by root 2 is equal to v times 1 by root 2, or in this implies u is equal to v. Let's see which option is correct. Yeah, u, v is right. Save that, go to the 10th question. A block of mass m is in contact with the cart C as shown. The coefficient of static friction, the block and the cart is mu. The acceleration alpha of the cart that will prevent the block from falling satisfies which equation? Let's see, quickly see that. Yeah, let me clear that. Now, if the see, now we can see the constant acceleration with now we can see that the cart is now going to move with that constant acceleration. Let us take that. The acceleration of the cart AC is equal to, right? Now the pseudo force which is acting on the mass, let us take that as F is equal to MA. Right? Now force of friction is given by frictional force. F is given by mu n. Right? So for horizontal equilibrium, you know F is equal to n. Right? F is equal to n. N is going to be the reaction member. Now you know F is equal to mu times ma. Because the force is now going to be purely due to the frictional force, F is now going to be equal to mu by E. So the block will not fall as long as F is lesser than, greater than equal to mg. This you would have seen in the revision notes also, right? Yeah, sorry, here. Right? We saw here. See? We saw here. You can apply that. So F is greater than equal to mg, or now you can substitute in the place of F. I can put it as mu ma is greater than equal to mg. Now cancelling both, you can get A is equal to, A is greater than equal to g by u. Let's see which option is correct. D option is correct. D by mu, that is the correct option. Let us go to the next one. Now you can see the FBD is given here for this diagram. Let us look into the question. The smooth block is released at rest on 45 degrees inclination and then slides a distance dv. The time taken to slide is x times as much to slide on rough incline than on a smooth incline. What will be the coefficient of friction, we are asking. So the FBD is clearly given. So there is no need for you. Just look into the diagram and apply the formulae. It is now going to be pretty easy. Let's see. Now now you can see that the FBD is given for on a rough surface. So obviously it is now going to be A is equal to G sine theta minus mu G cos theta. Okay, G sine theta minus mu G cos theta. What is now going to be the time? X time. Look into the question. He says the time taken to slide is X times as much to slide on the rough inclined plane than on the smooth. So that is why we are taking it as XT. Now let us calculate the distance. S is equal to UT plus half AT squared, which is equal to, now you know the initial velocity is 0. So plus half into, in the place of A, we'll have to substitute this. Okay. So G sine theta minus UG cos theta, right? Into x t the whole square. T is now going to be x t the whole square. This is now going to be on the rough surface. Okay. Now let us calculate for smooth surface. So in that case, A is now going to be just G sine theta. Right? A is now going to be just G sine theta. Time is now going to be just T. Time is T. So here S is now going to be 0 plus half into, in the place of A, put G sine theta into T square. Now let me take this as equation 1. Let me take this as equation 2. So solve both. You can see that mu is equal to 1 minus 1 by x square. So let's see which option is correct. Oh, let me go to the test again. It's the 11th question, right? Yes. Yeah. So option A is correct. That is, since it is now going to be kinetic friction, because the object is moving, right? So we are going to take it as mu k. That is now going to be, since the object is moving. Remember, even though we might have mu s, you have A and C as same option, but you'll have to see that it is now going to be due to the kinetic friction. So option A is correct. Save that and go to the next. A box is gently dropped on a conveyor belt in an airport moving at the rate of 3 meters per second. The coefficient of friction between belt and box is 0.5. How far will the box move on the belt relative to the belt before coming to the rest? Let's quickly solve. We are running short of time. Let the initial velocity of the box and the relative to the belt be, it is given as 3 meters per second. And let it be in the backward direction. Okay, that is it is now going to be in the backward. Let me put it the arrow mark as this. It is now going to be opposite of the moving belt. Okay, so it is now going to be 3 meters per second in the backward direction. Now the box experiences maximum frictional force. So F is equal to mu R, which is equal to mu mg, maximum frictional force, mu mg. Now you know A is equal to F by m, which is equal to mu mg by m. Cancel out m and m, which gives you mu g, right? So, which is now substitute the values. It's given as mu is 0.5 and g is 9.8. So, let's see what is g is given as. G is 9.8. You can substitute and find out the value. You can multiply and find out it is nothing but 4.9 meters per second square, right? So which option is correct? 4.9 in the forward direction. Before that, we have not yet solved. Yes, we have not yet solved. This is now going to be in the forward direction. We have found out the acceleration of the belt now. Now the box is coming to rest in a distance s. Okay, so we have to find out there. Let us use this formula. B squared is equal to u squared plus 2as. Obviously, it is coming to rest, so the final velocity will be 0. U is 3 squared, minus 3 squared, right? Minus 3 squared plus 2 into A is 4.9 times S. We need to find out S. So it is now going to be in the negative value, obviously, because it is now going to the opposite direction. So S is equal to minus of 0.918 meters. Okay. So this negative sign shows that the box moves in the opposite direction of the motion of the belt. Now look into the options. Which of, yeah, see, D is correct. So remember children, the first half we did only the acceleration part. Don't think that the problem is over. We have to calculate the distance with which it is now coming to rest. So save that, go to the next one, 13th one. In this figure, A is equal to 10 kg, B is equal to 5 kg, and the coefficient of friction between A and the table is mu is equal to 0.2. Find the minimum value of mass C, which may stop from slipping. Mass C should not slip. That is the condition given. Okay. Now look into the diagram. A is now going to have a total mass of m plus n. Now A and B are going to be stationary. So the net force on each is now going to be 0. Remember, A and B are now going to be stationary. So the net force on them is now going to be 0. So suppose if m is now going to be the mass. Okay, let me take, if m is now going to be the mass at C, right? And let m1 be the mass of A, then then it is now given by, at A, n is equal to mu into mu static, okay, mu s into m plus m1 into g. We have taken mass of A as m, okay, m1. So, and mass of mass of C is n. Okay, so it is at A, it is now going to be, what is now going to be the reaction now? N is equal to mu s into m plus m1 into g. Okay. This is at A, and at B, let us calculate that. So here, you know, it is now going to be, quickly look into the figure. It is now going to be the tension due to the string. So if we take the mass of B as m2, then I can write it as, at m2, this now going to be T is the reaction here. So T is equal to m2g. So mass of B is equal to m2, since we have taken the mass of B. So now let me take this as 1 and let me take this as 2, equation 2. Now you can see from 1 and 2, you can see that normal and both of them are equal. So you can now equate both. So T and N are equal. So I'm going to equate both. So M2G is equal to mu S into M plus M1 into G. Right? From this, we need to calculate M, small m. So M2, when I simplify that, I get M2 minus mu S into M1 divided by G into, oh, G and G will get cancelled. So it will be simply mu S. Or you can simply write it as M2 by mu S minus M2. Now we know the values, substitute, that gives you 5 by 0.2 minus 10, which is equal to 15 kg. So M should be 15 kg. Option D is correct. Save that, go to the next. Two blocks of 100 kg and 50 kg connected by a massless string passing over a frictionless pulley rests on a frictionless inclined plane, inclined at an angle and at angles 30 degrees and 60 degrees. What is the acceleration and which way the system moves? Take G as 10 meters per second. You can look into the figure. See, this is given as 30 degrees and this is 60 degrees. This is 100 kg mass and that is 50 kg mass. Let us quickly solve that. Okay. Now looking into the, let me draw the FBD for this. So this was 30 degrees and this was 60 degrees. And the mass here is now going to be 100 and the mass here is 50 kg. So a pulley is going here and the strings are now going to be here. So this is now going to be the tension. Right. So let this be the acceleration A. So if this is now going to be, the mass is now going to be acting along in this direction. So now again, we can resolve the two components as, so we can see the mg's cos theta component is now going to be cancelled out by t. So we'll have the only component which is acting is now going to be m1g sine theta 1. That is for this one, m1g sine theta 1. And here it is now going to be m2g sine theta 2. The cos component is now going to get cancelled, so we are not bothered about that. Okay. So that means now look into the first one, that is 100 times sine 30 minus t is equal to ma. Or this implies, now sine 30 you know is half. So that is now again you have g as g is equal to 10, it is given. So when you calculate, you get it as 500 minus t is equal to 100t. Or from this you get, okay, let us have this as equation 1. Now for the 50 kg mass, it is now going to be t minus 50 times sine 60 is equal to a into 50. So that would give you t minus, because sine 60 is root 3 by 2. So when I calculate that 50 times sine 60, when I calculate, that gives 433, right? So 433 is equal to 58, right? 58. Now let me take this equation as 2. Now solving, or you add both, you get it as 150a is equal to, sorry, 150a is equal to 67, or from this is equal to 67, or from this you get a is equal to 0.4, or a is equal to, this implies a is equal to 67 by 150, which works out to be 0.446 meters per second square. So that is, it is now going to be, this acceleration is going to be towards left. Okay. So let's see which option is correct. Option, yeah, 0.446 left. Okay. Click on. Now coming to the last question. A cyclist has to lean inwards when negotiating a curved unbanked road. The cyclist leans with an angle theta to the vertical. N is the normal reaction given by N is equal to mg, where m is the mass of the cyclist and the bicycle combined. The radius of the curved road is r. The force of friction is given by F is equal to mu n, where mu is the coefficient of friction. Assuming the cyclist skids, which of the following is true? Right? Let us see. Let me clear this. Let me draw the FBD. So this is going along an angle, so n. So obviously n is now going to be resolved into two components. Here, this is now going to be theta, remember, this is theta. So this is now going to be n cos theta, and this is n sin theta. Right? So the cyclist is now going to be at this point. Okay, so this is now going to be the, so his weight is now going to be along this direction, mg. Obviously, the centripetal force mv squared by r is now going to act along towards the center. That is mv squared by r. I have marked that out. Now F is equal to mu times n, which is equal to mu mg. We know that. So cyclist will skid if the centripetal force mv squared by r exceeds the frictional force. That we have clearly mentioned in the revision notes also. Sorry, this is so you can see he will skid when the when it is going to exceed the frictional force. Okay. So that means what should be the, so F should be equal to mg, or yeah, F is equal to mu mg. So when will he skid? If v is greater than root of mu g r, right? When it is going to be greater than, see, root of mu g r, we have given in the revision notes. So when you remember this, you can straight away click that. You need not even draw the diagram and do all these things. Straight away you can go there. So click on which option? Root of, so option A is correct. Okay. sorry, option C is correct. Yeah. We can as well go there. It is greater than, the cyclist will skid if mu is greater than mu g, right? Save that. And so you shouldn't be confused with lesser than and greater than symbols. Mark the correct option, save, and you can end the test. And finally, you can go and end the tests. The results will be loading. Obviously, you can see that the correct answers are all marked in green, and the incorrect answers are now will be marked in red. The unanswered, of course, we went again. So it is now the yellow boxes show the unanswered questions. Suppose you have a doubt and you have answered some question wrong, then you can as well go to that question, recheck it. So click on this, suppose question 3 was wrong. Click on that box. You can see the fireman has to carry. You can see the correct option there along with the explanation. See, the explanation also is given here. You can as well check your answer and verify it. Like this, you can redo this test again and again until you are going to be finally done with the concepts. You are thorough with the concepts. Once you are thorough, you can as well go with the long tests, right? So that is now going to be right. So in today's class, we have spent mostly, I solved all the problems. I hope all the concepts which we underwent here are clear to you. If not, go to the revision tests which we have here. You can as well look into all the concepts, by heart everything. It's enough if you go through the concepts again and again. That is enough. And you can as well, once you are done with these concepts, you can be pretty sure you'll be consuming, your consumption of time will be very, very less. You can go on clicking the correct answers with confidence. Is that right, children? So see you tomorrow with the next chapter, Work, Power and Energy. Until then, goodbye from Mrs. Vijayalakshmi. Bye, children.